It's time for Universal Science Concepts Day 2. Today we're going to be talking about the metric system, and of course you will note the lovely pen in the corner, and you know what that means. Despite the fact that this country seems to want to avoid the metric system is really an easy system to use because it works in powers of 10. My question for you would be, let's see, how many inches are in a foot? Everybody knows that. 12 inches in a foot. How many feet are in a yard? Everybody knows that. 3 feet in a yard. How many yards in a mile? Exactly. Nobody knows. Or how many feet in a mile? Who knows? Who cares? But if we go through the metric system, it is so much easier. This is why we love the metric system. Once you understand how to use the base units and the prefixes, then you're all set with the metric system. There's no weird conversions that are going to go on. In this class, we are going to use the MKS system of the SI units. SI stands for Système International. Yes, that's French. You can tell by the way I pronounced it, which means the International System of Units, or the metric system. The MKS part refers to the basic units, or the main units, that we are going to use in this class. MKS stands for meters, kilograms, and seconds. So MKS, meters, kilograms, seconds. That means most everything that we use in this class will break down into meters, kilograms, and seconds, at least for the first half of the year. Now, if you look on the front of your reference tables, you're going to find the prefixes associated with the metric system, or the International System units, and they're shown at the bottom left-hand corner of the reference tables. While I know you have learned other ways to use the metric system to convert between metric units, I'm going to give you a different way that matches with this chart that's in our reference tables. Quite frankly, I don't care what system you use, as long as you recognize that you're not going to be able to Google it. You're going to have to know how to convert on your own. So we are going to start by talking about how to convert between these metric prefixes. I know you have maybe learned other ways of converting between these prefixes, but I'm going to show you a method that goes with the reference table. It's pretty straightforward, as long as you understand scientific notation, which I know you do because we talked about it yesterday. The first thing we have to do for our prefixes for the power of 10s, or powers of 10 chart in our reference tables, is we have to figure out where the base unit goes. By base unit, I'm talking about the unit without any prefixes on it. For instance, meters. You know, we add kilo to it to get kilometers, or centa to it to get centimeters. But the base unit is meters. Seconds is a base unit. Grams is a base unit. So where do we put this base unit? If you have your reference tables out, which you need to do right now, because I'm going to have you add this to your actual reference tables, so get your reference tables out. You're going to put a star between kilo and deci on the chart, and also put one between 10 to the third and 10 to the minus 1. So you can see that illustrated right here, the star between kilo and deci, and the star between 10 to the third and 10 to the minus 1. So what that means is our base unit goes there. So meters would go between the prefix kilo and the prefix deci, because if you look over here, you'll notice that kilo is a positive power of 10, 10 to the third, and deci is a negative power of 10, 10 to the minus 1. Our base unit power is 10 to the 0. So what I want you to do is write that at the bottom of the chart. Put the star down there to indicate what this is, what the star means that you just wrote before, and wrote base unit, which equals 10 to 0. Just like you see here. Base unit equals 10 to the 0. I didn't put the rest of the chart on here because I didn't think you needed it at this point. I was just trying to give you some perspective. But this goes at the bottom of the chart. This slide just tells you what I already told you, what base unit means, those metric prefix, or those metric roots. Now that we have this, we can convert between any two units very simply. So you need to write down convert between any two units. All we have to do to make this conversion is subtract the powers of 10. So if you wrote down convert between any two units and add by subtracting the powers of 10, it makes sense. It makes sense. It's basically a sentence. When I say by subtracting the powers of 10, what I mean is you're going to subtract the ending unit's power from the starting unit's power. Ending unit's power from the starting unit's power. So whatever the initial unit's power is, take away from that whatever the ending unit's power is. I'll do an example. It'll become crystal clear. I realize right now it's clear as mud. So let's suppose we want to convert 4.85 centigrams to megagrams. So the first thing we're going to have to do is figure out what these prefixes have for powers of 10. So the question is, what is the power of 10 for centa, and what is the power of 10 for mega? You look in your reference tables, you see that centa is 10 to the minus 2, and mega is 10 to the 6. So now we know what the powers of 10 are for those two prefixes. So what we do is subtract the ending prefix's power from the initial prefix's power. So the ending prefix's power is positive 6, and we subtract that from the initial prefix's power, the minus 2. So 10 to the minus 2 minus a positive 6. Negative 2 minus 6 is negative 8. So this becomes 10 to the negative 8. What that means then is if I want to convert 4.85 centigrams to megagrams, all I've got to do is put in this times 10 to the minus 8. 4.85 centigrams is equal to 4.85 times 10 to the minus 8 megagrams. Piece of cake. Let's do another one. How about if we want to convert 2.1 times 10 to the minus 5 meters to millimeters? Now we've thrown a monkey wrench in here because we have a times 10 to the minus 5. We have a power of 10 already in there. Let me show you how we do this. First of all, we've got to figure out the powers of our prefixes. Notice there is no prefix on the meters. It's a base unit, but we have the prefix milli on our final unit. So therefore, the power of 10 for meters is 10 to the 0, and the power of 10 for milli is 10 to the minus 3. All we have to do now is subtract those units. So 10 to the 0 minus a minus 3 is 10 to the third. But we're not done yet because we already have, we have this 10 to the third, we already had this 10 to the minus 5, so we've got to put those two together. So we add the new power to the power of 10 that was already given. Add the new power to the power of 10 that was already given. So I have 2.1 times 10 to the minus 5 meters. That's going to be equal to 2.1 times 10 to the minus 5 plus 3, because we came up with plus 3. We're adding the plus 3 to the minus 5 that we already had. So that'll be how many millimeters we have. Of course, minus 5 plus 3 is going to be minus 2. So 2.1 times 10 to the minus 5 meters is the same thing as 2.1 times 10 to the minus 2 millimeters. See, just subtract those powers of 10 exponents and then add that value to whatever was already given up there. Okay, so here is your turn to try one. On the next slide, I'm going to give you a problem to try. What you can do is pause it, try it on your own, and then see if your answer agrees with the answer I come up with. By the way, if you hear a snoring sound in the background, that's my dog. He's sleeping next to me. What we want to do here is we want to convert 0.008 millimeters into nanometers. So the question is, what do we do first? This is where I pause to let you figure out that answer. Do, 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 do. Okay, yeah, I can't sing. I'll stop doing that. So we're going to try to come up with, of course, the powers of the prefixes. So I need to know what the power for milli is and the power for nano is. Use your reference tables. This is not something you need to memorize. Look it up. We see in the reference tables that milli is 10 to the minus 3, and we see nano is 10 to the minus 9. So all we have to do to get the power for the conversion here is do 10 to the minus 3 minus a minus 9. Minus 3 minus a minus 9 is, of course, the same thing as 10 to the 6th, because it's negative 3 plus 9. So that's 10 to the 6th. So as you can see, the answer is 0.008 millimeters is equal to 0.008 times 10 to the minus 6 nanometers. We just put in that factor of the power of 10 that we just came up with. This, of course, is not in proper scientific notation. If we want to put it in proper scientific notation, we can simply type it into our calculator and hit equals, and we'll find out that in proper scientific notation, it's 8 times 10 to the third nanometers. You could also do the conversion for scientific notation like we've taught before if you want to do it by hand. It's no big deal. You get the same answer. So what we want to do now is we want to write the actual formula that we're using in the reference tables above the prefixes chart. So the formula for converting is 10 to the I minus F, where I is the power of the initial prefix, and F is the power of the final prefix. So let's write that. Let's write that now right in our reference tables. So notice how I put it right here above the chart in the reference tables. So now I've got where the base units go, I've got what the base unit means, and now I've got how to convert. So voila, we have it all. Okay, this next part is defining for you some other unit terms that we will use in this class. The first term is fundamental unit. So what you want to do is put this term down and then write this as the definition. A fundamental unit is a single unit by itself. So for example, centimeters. I don't know if you can see that or not. Oh, wait, I know how to move this. Oh, look at that. An example of a fundamental unit would be centimeters. It's a single unit all by its lonesome. Doesn't matter if it has a prefix on it or not. As long as it's a single unit by itself, that's a fundamental unit. The counterpart to the fundamental unit occurs if we have two or more fundamental units used in combination. It's really hard to say fundamental unit really fast. Anyway, if you have two or more fundamental units used in combination, this is called a derived unit. So write down the term derived unit, and if you need to, rewind this video back to the definition, which is two or more fundamental units used in combination. An example of a derived unit that you all know would be miles per hour, because it has both miles and hours in it. Two or more fundamental units used in combination. Got it? So let's test whether or not you've got it. Seconds. Is that fundamental or derived? Pause. Right. It's fundamental. Nice job. Meters per second squared. Fundamental or derived? Derived, of course. You're amazing. Meters squared. Fundamental or derived? This one happens to be a little bit tricky because you may say, well, all we have there is meters, so it must be a fundamental unit. But because we have meters twice, it's meters times meters. That's two fundamental units combined together. Meters per second is actually, meters squared is actually a derived unit. Two units combined together. It didn't say in the definition it had to be two or more different fundamental units. It just said two or more fundamental units in combination. So meters squared is actually derived. All right, what we're going to do in the next class is we're going to become familiar with the sizes of these metric quantities, because that's one of the things that they test on the Regents exam. For instance, do you know how much mass is a gram? If you don't know how much mass is a gram, or what common object has the mass of a gram, for instance, then you're not going to be able to answer questions about how big, relatively speaking, a gram is. So we're going to focus on that during the next class. All right, that's it for today. Adios.